Greetings, YouTube. My name is Ed Gomez, and I'm a senior .NET developer and lead architect with over 30 years experience in software development. I've worked at many major financial institutions. I've been doing this for a while, and everything I'm about to teach you comes from real-life experiences. I'll take the theories and concepts and show you their practicality and business use. Okay, so we're going over the S.O.L.I.D paradigm. The S.O.L.I.D paradigm was coined by Robert Martin. Okay, so let's look at the S.O.L.I.D paradigm. You have the single responsibility principle, you have the open-close principle, you have the list-cost substitution principle, you have the interface segregation principle, and you have the dependency injection principle. Without proper knowledge, all this is meaningless. I'm going to show you some examples. You go out to Wikipedia and they explain all these things, and you're trying to figure out, well, damn, how can I use this for things that I need to do? I have the experience, and that's why I'm going to take these convoluted explanations and make them very simple to follow and give you an understanding why it's so important to understand these principles and just make it in basic English translation. So let's go to the next. Okay, let's start with the first tongue twister. In object-oriented programming, the single responsibility principle states that every class should have a single responsibility, and that responsibility should be entirely encapsulated by the class. All its services should be narrowly aligned with that responsibility. The heck does that mean in English? The English translation is, an object should only have one reason to change. Why is this important? When I first started coding many years ago, and I was doing basic and then quick basic and then visual basic. Eventually I was doing WinForms. And in the WinForms, basically, you know, if you clicked on a command or on a button, you put your code in there. And we did two-tier programming. We had a front end, and then we had a database in the back end. And all your stuff was, anywhere you clicked on, was always embedded inside the form. And you can get stuff up real quickly. In fact, I used to do that with Access. I used to be able to create some Access applications, and it was really quick to get up. But man, let me tell you, it was really difficult to maintain. And why? Because back then, I was violating this principle. Now, I'm giving you a little overview, but I'm going to explain and show you how simple it is and what this really means. But let's go through all of the S.O.L.I.D principles. Okay, so the next one is the open-close principle. An object should be open for extension, but closed for modification. What does that mean? English translation, add features without affecting the base code. And I'll show you how these things, and I'll show you also how you'll use design patterns to implement this type of thing. But anyway, let's just get to the next one. This one sounds really scientific. This is the list-cost substitution principle, and there's a definition of it on Wikipedia. Get this. Liskow's notion of a behavioral subtype defines a notion of substitutability for mutable objects. That is, if S is a subtype of T, then objects of type T in a program may be replaced with objects of type S without altering any of the desirable properties of that program. Correctness. Gosh, what the heck does that mean? I got simple translation, but they should say English translation. But anyway, you should be able to substitute an inherited class in place of its base class. An inherited class must not change the initial implementation of the base class. I'm going to give you a very simple example, and I'm going to give you some code reviews when we get to that. Okay, and here's another one. There's the interface segregation principle. Again, from Wikipedia. ISP splits interfaces which are very large into smaller and more specific ones so that clients will only have to know about methods they are of interest of them. That doesn't sound too bad. In a nutshell, no client should be forced to depend on methods it does not use. English translation, you have an interface that has 10 methods when all you need is 2. If you control the application yourself, just make an interface. Go ahead and make a brand new interface to just have what's specific to the client. And I also have examples of this following. So let's get on to the next one. Okay, so the next one is dependency injection principle. Again, and this is from Wikipedia. Dependency injection is a software design pattern that allows a choice of components to be made at runtime rather than compile time. This can be used, for example, as a very simple way to load plugins dynamically or choose to mock objects in test environment versus real objects in production environments, okay? What does that mean? English translation. You need the ability to inject objects that will do work for you and pass them into your client's constructor. Basically, you will always work with an abstraction, never with a concrete class. So I'm going to show you that you're going to take interfaces and inject them into your constructor, and that's how the dependency injection works. But you're going to see it's going to all make sense as I start showing you examples of that. Okay. So everyone buckle up and put on your thinking caps. Let's start with the single responsibility principle, which we're going by. The English translation is an object should only have one reason to change. Well, let's see. We need to, whenever you start anything, you always have to know what is it that the user wants, or in other words, what are the requirements. So let's look at the functional specs. Give me 1 second to find that. Okay, let's look at the functional specs. So the user submitted maybe what we call a BRD, which is a business request document. A lot of places have these formal documentation for requesting stuff, but we'll get into that. The book covers that a lot, but we'll get into that later. But anyway, these are the functional specs. Let's say it's a brand new system, and this is what they want. Okay, this is a finance application. The first thing they want to get the latest market data, bid or ask spread. Don't worry about what that means if you don't know what it means. These are just specs for now, okay? Well, there's another section on that in the book. Okay, allow different data sources. We could be getting data from Reuters, Bloomberg, or Market Pro, or any one of these other data providers. Anything that goes on in the market, if we have some sort of financial application, we need to get that data so we can process it. You know, that's where our data comes from, okay? Now, there are also different exchanges. They want to be able to deal with domestic, the New York Stock Exchange, Chicago, and Pennsylvania. International, they also want to deal with the London Stock Exchange, Paris Exchange, Tokyo, whatever. Next, they want the ability to restrict securities. They want to be able to do it by region, security type, or company. They also want to allow the execution on an exchange with the best price. I actually worked on one of these applications for a major financial firm. I won't say its name, but that's one of the first things I did when I worked for Phonetics. Well, anyway, the next thing is allow the user to select exchanges, favor one over another, get the best price, execute a trade when a specific price point is met, okay? Allow it to execute in batches. So there's a whole bunch of stuff in here. How do we get a handle on how do we actually start? Well, based on these specs, let's look at the different types of responsibilities. I see we have about 4 separate responsibilities, okay? And let's bring that up. I have a little screen for that here. All right, because it's saying about it needs to get, you know, some different exchanges. So, okay, there's market data. And we mentioned that, you know, there are different providers, Reuters, Bloomberg, and stuff like that. So we need to get market data. Execution, we need to be able to submit trades and execution and do all kind of stuff. We're also going to need a data access layer. You know, that's okay. If they go to Reuters or Bloomberg, you got to be able to access it, right? And another thing they requested is they want to be able to restrict the data. Okay, so we know basically the different things we need to do. We can break it down into 4 different components. So we got that so far. So we're getting a little bit closer, but we're still not there yet. Okay, so let's look at some code. I had created this trade processing system here. Let's just look through it. This is called the bad SRP example. I wonder why. Okay, so we have in this class, we have an enumerator, trade type. It's a buy or a sell. Okay, remember we want to know what bids are asked. It has a list for a restrict list. It's got a constructor called the trade processing. Okay, it calls a function called get restrict list. Let's look at the next thing that's here. Here's a summary. It says market data, references data access, Oracle, and Sybase. Okay. And here it turns out a list of these tickers. All right. Another one, it has the trade process get market data. It checks to see if it's restricted. It has this ASE helper. It's got this trade process that's in there. Let's see what else it has. It executes this data set to go ahead and get some data. It needs a connection string. It's got that. Here it has is restricted. Here it has another function for finding the ticker. Here it has a get restrict list, okay, and it calls this ASE helper. Remember, we need a data access layer, so this ASE helper is the data access layer for getting a restricted list. All right, what else do we have? Here we have a Boolean that takes a trade process. Code will be added later. We'll look at that. And we have some functionality to execute a trade. And we have some constants for a connection string. And we also have a class called trade process. This trade process basically has a ticker, date and time. Here's where we get information about the bid or the ask. Remember, that's one of the things that they asked for. Here's the ASC helper. This ASC helper basically is to do the database access, okay? So, go back to this trade processing. We basically have all of the functionality in that they've requested, but it's all in one class. It has all these different functions. It's, you know, we broke it down into 4 different things. We are getting the market data. We do have something for execution. See, we got to be able to find, get the market data. What else do we have in here? We should have, do we have a thing for getting the market data? Let's see, get restrict list. Yeah, so we have a thing. We have this collection here that we actually send back this information. You know, we agreed on that, so. All right, so I started to say separation of concerns before when I was saying the single responsibility principle. But basically, even though we know the different responsibilities, everything is still in one place. All right. There's another concept called the separation of concerns, which you can see the definition for it on Wikipedia. In computer science, separation of concerns is the design principle for separating a computer program into distinct sections so that each section addresses a separate concern. A concern is a set of information that affects the code of a computer program. A concern can be as general as the details of the hardware the code is being optimized for, or as specific as the name of a class to instantiate. A program that embodies SOC, which is called a modular program, modularity and hence separation of concerns, is achieved by encapsulating information inside a section of code that has been well-defined interface. Remember I mentioned about the interface, all right? Now, in the English translation, we say separate responsibilities into their own objects, all right? So you can see my solution, I started to break things down. So let me take this a little bit further. I'm gonna get this guy out of the way. Okay, so let's look at the left. The left is the bad SRP example. As I mentioned, we figured out what the responsibilities were, all right? So let's look at what we have on the right. So let's go to the bottom, and we have this enumerator we said was buy or sell. We had the enumerator inside that same class. I now have separated an enum of trade type, and that's what that guy looks like, okay? That's one part. Another thing here is I have my constants, right? So I go to my constants, I go into my settings, and I have my constants totally separated. So this is no longer needed. It's been extracted out, all right? These constants are, you know, you could share these things. Remember, we want to make things reusable. You're not the only one that's changing your code. Someone else could come along, and someone else has to be able to come along and change your code. And just like the way we had, and I mentioned the analogy of the kitchen utensils, everything in a spot, and we mentioned the notebook, we have everything broken down. So if we look in here, let's break down the different things that we have. Okay, we have market data, right? The market data has get tickers and it has get market data. Instead, what I have is I have an I market data, and my R market data has get tickers and it has the get market data. To that, I have my services. I have a market data service. In my market data service, I have the let's say, get tickers and get the market data. Okay, so that's been extracted out. The next thing here, besides that, let's close this up again. Let's see how we close this up. We'll go over here. Okay, we'll look at the restriction. So let's close this guy, and let's close this one, and let's close this one we don't need. Okay, so now we're going to look at the restrict list. We have a get restricted, is restricted, and is restricted with some additional information. I don't know why we have that process, but let's see. So I go into my I restrict list, and I have get restricted list and is restricted with the ticker. So this one I think is just extraneous. We don't need it. I'll delete that. That was a mistake. Bear with me. Okay, so that logic now resides in the restriction list. We go to the restriction list. He inherits from that, and here he's got all his information. All right, so what else do we have? Let's close this up. And let's look at the trade execution. For trade execution, we basically just have an execute trade, and we pass it the trade process, which has basically the information that we want to process with, okay? The thing is, where is my data access? Well, let's go to the execute trade anyway. Here's a trade execution. We'll look at the I trade execution, which is here, right? You got that. Then we go into trade execution. So everything, you know, I don't care about there's no implementation. I'll add that later, but just so you get an idea. Okay, but the question here is, where's my data access? Okay, now if you look, and I've separated it, in that trade process first tab that we're looking at, we do calls. I have them actually here because it's easier to see. But the get market data is making a call to the ASC helper, and so is the get restrict list, because in our scenario, the data happens to reside on a database somewhere. So now, if any changes happen to the database, I now have two breakpoints that I have to now resolve. I have an ASC helper here, and I'm making a call here. Now, there's a principle called the Hollywood principle, and that states, don't call us, we'll call you. You don't want to know that much. Your client should be as dumb as possible. Your client just wants to work with data. It doesn't care what it is. We agreed that, look, I want to look at a bunch of trade process information. I need to know whether it's restricted or not, and I don't care. Just get me my data. So that's what the Hollywood principle is. Just let me call you, and you take care of that information. I don't know what the background is. I just know this is the data that I need. So get it for me. All right? This is now tied to Sybase. Well, what if some point, and I've seen this happen before, where you go from one database to another. This thing knows a little too much, and this code now is very brittle. Not only is it just brittle, but it's all compact in one thing, and you could imagine someone else coming in and trying to change this. So what we ended up doing is, like I said, we separated everything, right? We're following the single responsibility principle leads into also the separation of concerns. We're just taking it one step further. We have a responsibility, and now we're separating it out, and we're creating our own objects. Okay, let me just pause this for a minute. Okay, so now let's look at the data access. Instead of having this person speak to the ASC helper, instead I have an I data access. And in the iData access, I get a data list, I get data, and I have get restrict list. So let's look at the data access. Okay, now, if you can even see the summary, currently data is retrieved from Sybase, but it can easily be altered to provide data from numerous data sources. Remember, one of the criteria of the functional specs was that they wanted to be able to work with different exchanges. They might be working with Reuters or Bloomberg or whatever, but they wanted to have different data types, different data coming from different data sources, okay? So now, here's an example. I could get the restrict list from a web call API instead, or a config file. It doesn't have to come from the database. But does my client have to know anything about that? It really shouldn't. Remember, the Hollywood principle, just don't call us, we'll call you. I'll tell you what it is that I want. Okay, so now we have the data access. Now let's look at the constructor on it though. In the data access layer, okay, it has the ASC helper, all right, and it also is going to store the restrict list. This is something we really don't need, so I can take this guy out. Let's take this guy because we don't need that. And I don't need this. Okay, that was a mistake. Okay, so the data access itself now calls the IASC helper. Now, if the database changes, I've only got one point of failure, is the data access. Now, all my clients, market data is going to be processing it, the restrict list. Let's look at the actual market data. Let's actually go to it just to see it. If you see the market data, he's saying data access, get me my data. Okay, data access, I want to get a data list. Data access, I want to get my data. And here's my ticker. Now, the restrict list. Remember, on the left, you saw that I was doing both times going out to the database for two different concerns. All right, what's my concern? My concern is getting data. Okay, I let the data one actually tell me what it is that it needs to do. And here's the restrict list, data access. Okay, get restricted list is restricted. All right, so right now I just have one thing that's responsible for getting the data. I have one thing that's responsible for checking to see whether or not it's restricted, and I have one thing for actually I want to know specific. I want market data, the information that's in there. Okay. Now, I have now a trade processor, all right? The trade processor is basically responsible, it's the global one, for doing things. If you look at the trade processor, what does it have? It has the market data and it has the restriction list. The market data itself is talking to the ASC helper. Actually, the market data is talking to the data access, which calls the ASC helper, and the restriction list talks to the actual data helper as well. Okay, and we also have the trade execution. All right, so I'm injecting it. Now, let's skip forward, or actually let's skip backwards and see if I can find it on this side. Even though we're talking about the single responsibility, at the current moment we're talking about single responsibility principle, we've now also brought in the dependency injection principle. Okay, you need the ability to inject objects that will do work for you and pass them your clients and pass them into your client's constructor. That's what we're doing right now. All right, so everything now is separation of concerns, made it modular. All right, it's very easy when you look at the solution, where is everything? All right, we also have broken down any points of breakage. If it goes somewhere, and you know, like I said here, I gave you the example, the ASC helper. Now, I only have to go to one place. If anything changes, if we move from whatever we're doing to a different database, or maybe we want to change it, it doesn't matter, because everybody's talking to the data access. And the data access in this case now is calling the ASC helper, but we can create other helpers for the data access, because no other client talks to anything else it doesn't know. All it wants to see is this trade process. That's it. You know, and it asks for that information, and that's also what brings in the Hollywood principle. Do not call us, we'll call you. So we've covered a lot here. We've got the single responsibility principle. We took it a little bit further out, and we got the separation of concerns. All right, now you can start to see the light, hopefully, how you figure these things out. And we've tackled now not only the S of S.O.L.I.D, we've also tackled the D of S.O.L.I.D. Now, the D, it's going to have a separate video on there, because from dependency injection, we're also going to go into IOC, which is the inversion of control. And I'll be covering that in a separate one. Okay, so I've got basically this group method. I had to do some refactoring. I had put the video on pause while I actually did it. But here's the left. Let's look at all the junk that's in the left. We have all of this stuff inside here going back and forth, and we need to change things. Now, if I had put in those 12 bullet items, this code would be tremendously long and be unruly to try to figure it out and how to do it, and how to actually maintain the thing. Forget that. Or reusability, forget that, okay? All of my stuff is reusable. I mean, anyone else can call my market data to get market data. Anyone else can call my restrict list to do the restriction. You know, it's reusable. Anybody can use it, not just this trade process. But we took all the code that's there. We still get the functionality, but instead we pass over and we inject, because we're programming orthogonally, I think it's pronounced. But basically, we pass along the responsibilities and the work to another object to do the work for us. So it's a lot easier to see everything. So we have the trade processor, we have the market data coming in. You notice that I don't pass in, although in the last video I just edited it. I had put the screen on pause and edited. I had the restrict list in there, but I don't need it, because the market data itself, if we look at the market data, let's bring that guy up for a second. The market data itself is actually it's not even the market data, it's the data access layer. The data access layer is the one that's actually checking to see whether or not something is restricted. So where is that here? It checks it over here. Is it restricted or not? So when it actually gets the data, it itself checks to see if the data is. So there's only one point that has to be changed. Okay, so the data access already has access to the restriction list. So it knows exactly what needs to be done. Okay, so we look at the market data. Where are we here? Okay, we don't need that. So we come back. So now we have a much smaller object, and we've passed along the work. The good thing about passing along the work is that had we needed to do this in the real world environment, we can have 4 individuals taking a different service, and we could all have worked in the same time, because we're programming to an abstraction, and in this case, it's an interface. I'll have a testing, unit testing and TDD lecture later on that's coming soon, but we're still tackling the S.O.L.I.D design, but the S.O.L.I.D design, and basically, I got to pause. Okay, so this is work that also could have been farmed out. You can create a JIRA. If you don't know what a JIRA is, I do have a section in the book about that. But you could have created subtasks so that 4 people could have worked on this. If you had the resources, 4 people could have worked on it. We could have one person working on the market data, one in the restriction list, one in the trade execution. It doesn't matter. But now we have this global thing called the trade processor, and it passes off. It goes out and request information from all these different functions. And it's a lot cleaner. If you look at the solution, all right, because remember, as I mentioned, you're not the only person that's actually working. Someone else may have to come in weeks later, months later, years later, and have to be able to change your code, all right, and be able to easily maintain. This right now is reusable. It's modular, and it's easy to use. So the next topic we'll be discussing, and most likely in a different video, will be the open-close principle. Once again, thank you so much for listening. Please like and subscribe, and look forward to more videos coming. Okay, I forgot to mention the links from my book titled Software Development Accelerated Essentials. What you didn't know you needed to know are available below. Just take a look at the table of contents to see the wide range of topics I discuss. The book is broken down into 2 components: building the company, which is how to develop maintainable code, and running the company, which includes production releases, data warehousing, job scheduling, and so much more. So whether you're a developer or an IT manager, there's lots of information available for you in a one-stop shop resource. Please consider leaving me a review at those links, and thanks in advance.